Okay, this is the last problem on homeworks from 7.6. First thing I do is I try to define the variable, so I'm going to go to the question before I read the problem. To minimize costs, it says use blank bags of brand X and blank bags of brand Y, so I'm going to assume those are my two variables. So bags of brand X, bags of brand Y. It says I want a minimal cost of blank money, which means my optimization function is going to be cost, and I am going to try to make it a minimum or the lowest possible value. Okay, then I want to scan the problem looking for my constraints or my cost function. Public aquarium is adding coral nutrients to a large reef tank. I'm looking for something with cost or something with brand X and brand Y. The minimum amounts of nutrients of A, B, and C that need to be added are 30, 16, and 24. Information about each bottle of brand X and Y is shown below. How many bottles of each brand must be added to satisfy? So I'm going to use the table to create my equations. So I can see the first column is the cost, which means the cost is 22 per bag X, 15 for brand Y. So that's what I'm trying to optimize. The next information they give me is about nutrient A. So in regards to nutrient A, it's 3 per bag of brand X, 9 per bag of brand Y, and then what about it? Do I want to be lower or higher? Okay, the minimum amounts of nutrients A, B, and C that need to be added are 30, 16, and 24. So the minimum amount of A is 30. If the minimum amount is 30, it could equal to 30 or it could be higher than 30, but it has to be at least 30. Okay, I'm going to go through and do the next two the same way. So for nutrient B, 3x plus 2y. The minimum amount for brand B is 16. Since it's a minimum, it could be greater or equal to that amount. Okay, and then brand C, 7x plus 2y has a minimum amount of 24 units. So those are my inequalities. I'm going to go ahead and graph it so I can find the feasible region. I calculated my intercepts and I'm going to estimate about where they're each going to go. So 10, 0, we'll put that here. 10 thirds is 3 and a something, so maybe around here. It's actually 10 and a 3 and a third. Okay, that's my blue line, and I want to keep in mind because this is the minimum amount, it's actually going to be above this line that I'm looking for an optimal region. Okay, for my next inequality, the x-intercept is 16 thirds, which is 5 and a third. So let's move it way closer. Y-intercept is 8, so much higher. It is solid, and because this is the minimum amount, it's going to be above that line. And then my last constraint, 7x plus 2y is greater or equal to 24. Let's see, 0, 12 is my y-intercept. X-intercept, 24, 7, which is 3 and something. Okay, so my feasible region is actually this unbounded area way out here while I stay in quadrant 1, which makes sense that I'm trying to minimize my cost, because if it was trying to find a maximum, because it's unbounded, I would have no idea what the maximum is going to be. Okay, so I need to list my vertices, which would be this one, this one, this one, and this one. And it was important that I graphed it, because if I had not graphed it, I might have thought that this vertice, or this vertice are important, and they're not important at all, at least not in terms of making this feasible. So 0, 12, 10, 0, and then I am going to have to calculate the other two intersection points. Okay, I used elimination. I calculated one of the intersection points to be 2, 5. Then I just need to find this fourth vertice of the solution region, which is my purple and my blue line intersecting. And then for my last vertice, I found 4, 2. So I found all the vertices of the solution region. So one of those must produce the optimal value, which in this case, the question is asking me for the minimal cost, so I'm looking for the lowest possible value. Okay, so use your calculator and calculate the cost for each of those. Okay, so after calculating the cost at each of those points, this one is the lowest, which makes it the minimum. So now I'm going to answer the question. So what am I trying to use? Use 4 bags of brand X and 2 bags of brand Y for minimal cost of 118. And normally if it's a cost, it's going to be a minimum. In this case, they told you it was a minimum. Even if they had not told you it was a minimum, if they asked you to optimize cost, you want your cost to be low because it costs you less money.